We've learned that during a collision, the momentum is conserved. That means the initial momentum has to equal the final momentum. So what we're going to do in this experiment is we're going to have one car sitting still, and we're going to take another car and have the car moving with an initial velocity. The first car is going to hit the second car, and then they're going to stick together after the collision. That's a perfectly inelastic collision. And as you see, the final velocity will be a little bit slower than the initial velocity, but when we do the calculation, we'll find that the initial momentum is equal to the final momentum. Let's remind ourselves what momentum is. The momentum is the mass times the velocity. So in this case, I'm going to have m1 is going to be the mass of the moving cart, and it's going to have an initial velocity of v initial. m2 is the mass of the standing still cart, and that's going to have an initial velocity of 0. So the initial velocity of the system is m1v1. The final velocity is going to be m1 plus m2 times v final. I said that wrong. The final momentum will be m1 plus m2 times v final. And because the final momentum has to equal the initial momentum, we can then solve for the final velocity. The final velocity should be m1 v1 over m1 plus m2. Here's the mass of m1, the first car, the moving car. Here's the mass m2 of the second car. This is the car that will be standing still initially. And just like before, we're going to be varying masses by adding little masses onto the cart. Here are the masses we'll be using. You see they can fit right there. They're all very, very close in mass, so we'll just take the mass of one of them and assume they're all the same. And this guy has a mass of 124. Let's look at another one and see how much variance there is. Well, how about that? So for this first trial, we'll just have the two cars alone with no masses on them. So I'm going to give this guy a push. Then he slows down. And if we look over here, we see we have an initial velocity and a final velocity. So here you see the initial velocity just before the collision is 0.531 meters per second. And then immediately after the collision, it's 0.271 meters per second. Now I've put two additional weights on the initial cart and no weights on the second cart. And let's collect some data. There we go. And here we have an initial velocity and a final velocity. Here you see the velocity immediately before the collision. And here you see the velocity immediately after the collision. Notice that it didn't slow down as much this time because the incoming cart had more mass than the cart that was getting hit. So now I've put 4 masses on the incoming cart, the moving cart, and 0 masses on the cart that's standing still. Collect a little data here, give it a little push. And I think I'll do that one again. This is a redo with the first cart having 4 additional masses and the standing still cart having no additional masses. Let's collect some data. There we go. And there you see I gave it a little bit more of a push. But what we're interested in is the relative velocities, as we saw before. So let's see what those relative velocities are. Here's the velocity immediately before the collision. And here is the velocity immediately after the collision. Now I've removed the weights, the additional weights from the incoming car, the moving car, and I've added 2 weights to the car that's standing still. Can you predict what the difference will be this time? Let's collect a little data, give them a push, and they didn't stick, so we'll have to redo that one. Here's a redo. The incoming cart has no additional masses, and the standing still cart has 2 additional masses. Give it a little push. And there we go. And as we might have expected, it slowed down quite a bit more. Let's see, here's my initial velocity right here. And here's my velocity right after the collision. This time, the incoming cart has no additional masses. The stationary cart has 4 additional masses. So you can make your prediction about what will happen. As we see, there was a much bigger speed change than last time, and we can find our initial velocity there, 0.851, and then our velocity immediately after the collision is 0.239.